going through the list that you guys gave me yesterday on the board. So if you want to write any of these things down, you certainly may. Some of them you may say, I know that about fractions from 4th grade, so I don't have to write that down. You decide. What do you want to put in your notes that would be helpful for you to know? Okay, so to begin with, to add and subtract rational expressions, every class told me, number one, you have to have common denominators. Because a rational expression is an expression that looks like a fraction. I agree 100%. Please do not add any fractions or subtract any fractions that do not have common denominators. Okay. The next line I have is an example of something that's probably new to Algebra 2, meaning you probably wouldn't have said this yesterday. We didn't have it on the board. And that is, in rational expressions, if your denominators aren't the same, so you check to see if you have common denominators, number one, and if your answer is no, you really should factor your denominators first to see if they share anything in common, okay? Because that will make the rest of your work a little bit easier. So a really quick short example, and I won't work out the whole thing, would be an example like if I had something like 3 over x squared plus 3x plus 2 plus 1 over x plus 1. I think anybody could look at that and say, okay, well, if I'm going to add those, I have to have common denominators, and I definitely don't have common denominators right now. But it's a little overwhelming on the left side there. Your denominator is a quadratic, x squared plus 3x plus 2. So what you really should do with that quadratic is, if possible, factor it. Do you have factors of 2 that add to make 3, the middle term? Yeah, 2 and 1, right? So we really could factor this to be x plus 1 times x plus 2. Okay, so I'm going to cross that off. And then now when you look at your denominators, do you notice anything that they might share? X plus 1. So now you can see they share an x plus 1. That second fraction really only needs to get multiplied by x plus 2 in the denominator. So that would help us decide, okay, we're going to multiply by x plus 2 in the denominator and x plus 2 in the numerator. And then I have common denominators. In elementary school, it's way easier for us to look at something like 3 over 8 plus 1 over 4 and see what they already have in common. Like, we know 8 and 4 share a factor of 4, so we'll just multiply that 4 by 2. That's harder for us to see if it looks like a polynomial, so you might need to factor first, okay? And that'll tell you if they share anything in common. I'll be real honest and say I'm never going to make it so they do, like if you had a quadratic, I'll never make it so they'll have nothing in common and you'd have to multiply by a full quadratic. You'd only have to multiply by like one missing factor. Okay. Other things that were brought up yesterday, what you do in the denominator, you have to do to your numerator, and that was in regards to like that multiplying piece. If you don't have common denominators and you decide, like in that example I did, that the second fraction needed an x plus 2 in the denominator, if I multiply my denominator by x plus 2, then I have to multiply my numerator by x plus 2. So that's an old fraction rule from 4th grade. You guys also told me that adding and subtracting really happens once you have common denominators just in the numerators. You actually don't add or subtract denominators at all. Some of your groups, and we'll look at some examples from yesterday, we'll use some of those same problems you did in the groups. Some of the groups realized that now that we're in Algebra 2, we have to be really careful with our plus and minus signs. when we're adding and subtracting in the numerator. So I'll do an example where I had to send a lot of people back to their small groups yesterday saying, watch your signs when you're adding and subtracting. But since all the addition and subtraction happens in the numerator, that means that you just keep your denominator once it's the same. Remember, don't add things that don't have the same denominator, but once you get the denominator to be the same, don't touch it. Leave it alone. Copy it over on every step. It's the same thing. Just keep it. And the last one is simplify your fractions. Of course, fractions should be in simplest form, or so that you can't reduce it anymore. And I think Riley said yesterday that means they don't share any common factors. Now, this simplify and reduce if possible, that's what we did on Tuesday, simplifying. And so just remember that now that we're in Algebra 2, to simplify means we're going to need to make sure numerators and denominators are totally factored. And then we just check if any of the factors are the same. Be careful on that very last step not to get what I call cancel happy and start canceling things that are terms added and subtracted with each other instead of things that are factors, things that are multiplied. Okay, so you have to be really careful with that. The best way for you to get more comfortable with that is the practice, doing your homework, doing problems. Okay, that'll make it a little bit easier. So again, those rules, most of them, all except one or two of them, are from 4th grade. And I just want you to keep telling yourself that when you work through these problems, even though they look different because they have polynomials, you are doing the same thing you've done for years and years. Okay. 4th grade was a while ago. Okay, so here's some examples, and like I said, the examples I do are going to be from yesterday's problems. So if you did your problems instead of on the whiteboard, if you did them in your notebook, you might have these written down. And then some of them are from the later problems, which not all groups got to. Okay, so this was an example, I think it was the second or third example that you did in your small groups. 5x over x minus 3 minus 3x over x, x minus 3. 5x over x minus 6 minus 3x over x minus 6. And think back to that list of fraction commandments or list of fraction rules. Number 1, you have to make sure you have common denominators. When you look at these two fractions, you should get a big smile on your face. Because what do you have? Common denominators, right? Rejoice. Be happy. It's a good thing. Don't shake your head. It's exciting. So when I have common denominators, remember you're going to keep that denominator x minus 6. You don't have to do any kind of work in the bottom part of your fraction. All of your work happens in the numerator. So you guys told me yesterday, just add or subtract whatever's in the numerator. I'm going to show more work than maybe most people would do. You could probably do this in your head, but I'm going to take 5x minus, because I'm paying attention to the sign right there, 3x. And you tell me that 5x minus 3x is 2x. So I have 2x over x minus 6. Now remember, don't get cancel happy. You may not cancel out the x's. You may not cancel out the 2 and the 6. Because in the denominator you have a subtraction sign that x and 6 are terms, not factors. So unless you have an x minus 6 factor in the numerator, this is all you can do. That's your answer. If you did your homework assignment from last night, numbers 3 through 8, I'm pretty sure they all came with common denominators. So they should go by pretty quickly. It would be like the 19 through 22, where you had to get common denominators that took a little bit longer. Here's a really good example. This is one I want to touch on because I sent a lot of people back to their groups. And I said, you need to tell your group to be really careful with your signs. So we have 5x plus 1 over x plus 2 minus x minus 4 over x plus 2. I'd start that the same way, like, okay, I have two fractions. I see that I'm subtracting them. And in order to add or subtract fractions, I need common denominators. And then I look at my two denominators and I think, joy, common denominators. I don't have to do any work in my denominator. I'll just copy it over to the other side. That is awesome. So I have x plus 2 in my denominator. You guys should really be a little bit more excited about that. Okay. X plus 2, that is awesome. Okay. And in my numerator, then I just have to do all my addition or subtraction in the numerator. Now this is one where you have to be really, really careful with your signs. And so I'm going to show more work than I would normally do. But in the first fraction, I have this 5x plus 1, which, that's fine. I have 5x plus 1. And then in between the fractions, I'm subtracting, so I'm going to have a minus there. But this means subtract the whole fraction. So it means subtract the whole numerator. How do we say the whole thing or all of it in math? So Hill says parentheses. Okay. So what I would do on this one, anytime I have subtraction and you have like more than one term in the numerator or the second fraction, it's really like those terms are in a set of parentheses saying, subtract all of us. And what that does for me is it says, this subtraction, this minus sign, it goes to the x, and it goes to the negative 4. You could also distribute it right here. But anytime you have a negative in front of something in math, a negative really is just a sign change. So if your numerator looked like x minus 4, the sign change for the whole numerator would make the positive x negative and the negative 4 positive. So it really should be negative x plus 4. Okay. A lot of people only subtracted x. And then they left 4 as minus 4 and tried to argue with me, but it is minus 4. No, it's minus negative 4. Minus negative 4 is plus 4. Okay, so you have to be really, really careful with your sign there. That gets distributed. So then in my numerator, I have 5x plus 1 minus x plus 4 all over x plus 2. Combine your like terms. 5x minus x is 4x. And positive 1 plus 4 is 5. If you remember that one from yesterday, a lot of groups gave me 4x minus 3 to start with. Okay, and that would be the sign that we didn't distribute our negative. So I think patience is a really good way to approach these problems. If you try to rush through and just be done with it, chances are you're going to make like a small sign error, okay, especially on a subtraction problem. And nobody likes to get the wrong answer. It makes us feel sort of defeated and makes us want to give up and not keep going. So in order to make sure you get the right answer, you got to take the time. Okay. Now I'll show one other example. Oops, I went the wrong direction. I'll show one other example. We'll actually do the one on the bottom. Let's see if I can pull this up. Actually do this one. Let's do 3x over x plus 3 minus 2 over x minus 1. I'm not certain if many groups got to this. I think maybe one group. Okay. But this is one where when I start looking at it and I see, okay, I'm subtracting two fractions. In order to subtract fractions, I have to have common denominators. And now when I look at my denominator, I have a little bit of a sad face because x plus 3 and x minus 1 are not the same. Okay. Now, you should make sure that those are factored as best they can be, but like x plus 3 and x minus 1 can't be factored any further. They are factors. So now you just say, like, what does this first fraction need that it doesn't have? It has an x plus 3, but it needs an x minus 1. Okay? They don't have x in common as a factor. X is a term because it's getting added with 3 or minus 1. So you can't just put like a minus 1 and a plus 3 on the back of those. You actually have to give them the full factor that they're missing. So like this first fraction needs x minus 1. The second fraction needs x plus 3. You can't just put a minus 1, you can't just put a plus 3 because those are not factors in the denominator, those are terms in the denominator. And then what you've done is you've created a common denominator. Look at both of your denominators. X plus 3, x minus 1. X minus 1, x plus 3, are they the same? Yeah. Even though they're switched around, multiplication is commutative. So now I just keep my denominator. I don't have to do any more work. And I would say don't multiply that out and get a quadratic. If you do, you might have to factor it later, which would be more work, and we're in the business of least work. So leave it in its factored form. Just copy the factors over. And then in the numerator, I can go ahead and do some of that distribution. 3x times x is 3x squared. 3x times negative 1 is negative 3x. Be really careful with this. This is what kind of 2? It's a negative 2. You're subtracting this. It's a negative 2 times x, so we'll get negative 2x. And it's a negative 2 times 3, so we'll get minus 6. I'll combine my like terms, 3x squared minus 5x minus 6, all over x plus 3, x minus 1. And how we talked about like our fraction should always be in reduced form. I should stop and like look at my numerator to see if I could factor it. This one's a little bit harder because the x has a coefficient of 3. But to check to see if it's factorable, if you took 3 times negative 6, that would be negative 18. And do you have factors of negative 18 that add or subtract to make negative 5? No, 1 and 18, 2 and 9, 3 and 6. Those won't make, so not factorable. And that's your answer. 3x squared minus 5x minus 6 all over x plus 3, x minus 1. That's all you can do. If this numerator was factorable, we would take the time to factor it and then see if any of the factors matched x plus 1 or x plus 3, sorry, x minus 1, and then we could cancel them. That example would be more like numbers 19 through 22 on yesterday's homework assignment. So it's worth your time to go back and do that homework assignment. We're going to do one other example before I give you your homework assignment for today. And I would say don't do today's homework assignment until you've gone back and done the homework assignment from yesterday, because today is more challenging. Well, not really, but kind of. There's more to keep track of. Here's what today looks like. This is called a complex fraction. Write this in your notes. Complex. How do I describe complex fractions? I mean, they're fractions with fractions inside of them. It's a fraction inside of another fraction. That's why it looks complex. The thing about complex fractions is they can always be written to look nicer. Okay? So we have x over 6 minus x over 3 all over x over 5 minus 7 over 10. And chances are you could problem solve your way to something a little bit nicer than what we're seeing right there. So does anybody have any ideas about like where we might start? Damon, you've got one.
X over 3 and x over 5 multiplied by 2 get common denominators for 5.
I mean, don't you see it almost as like you're adding or subtracting something in the numerator? You're adding or subtracting something in the denominator? So you need to do that first. So Damon says get common denominators. So I'm going to say step 1. Get common denominators in the numerator and denominator. Yeah. And I would guess a couple other people had their hands up. I would guess we'd all, if we looked at this long enough, we'd all say like, yeah, I could probably do that. Multiply this one by 2. So I'll have x over 6 minus 2x over 6. That's already looking better to me that they have common denominators. And in the denominator, multiply this first fraction by 2. So I have 2x over 10 minus 7 over 10. And I'm already feeling a little bit better. What might you do next? Yeah, do the subtraction. Do addition or subtraction. Now, sometimes a complex fraction like this one, you have to do it in both. Other times, you might only have to do this in one section. Like there's only something added or subtracted in the numerator, or there's only something added or subtracted in the denominator. That's nice, okay, when you only have to do it in one. We'll go ahead and do that. In the numerator, x minus 2x leaves me with negative x, and then I keep my denominator 6, all over 2x minus 7, not like terms, so I'm just writing 2x minus 7, all over 10, keep my denominator. Okay, so this is looking even better. Instead of having 4 fractions, 2 in the numerator, 2 in the denominator, now I have 2, 1 in the numerator, 1 in the denominator. Any ideas how we can get rid of this fraction over a fraction? Okay. She says divide it, and when you divide by a fraction, what are you really doing? Multiplying by the reciprocal. So I'm going to say step 3, multiply by the reciprocal. Multiply by reciprocal. Okay, so some of you might have learned this as something like keep, change. That's the fraction bar is going to change from division to multiplication, and change. The second fraction is going to flip. Or copy dot flip one of those. So I would write this out as negative x over 6 times 10 over 2x minus 7. Now, as soon as you turn it into multiplication, that's a problem from Tuesday. When you're multiplying or simplifying rational expressions, you want to make sure everything is factored. So I might check all my numerators and denominators, and they're all factored as best they can be. And then if you have any, you'll cancel common factors. Are there any common factors in the numerator and denominator of these two fractions? Can you cancel anything? The top and the bottom. Damon? 6 and 10 share a common factor of 2. So they could both reduce by 2. That'll give me 5 and 3. And then I really just have to write what's left over. Negative x times 5 is negative 5x. And 3 times 2x minus 7 I can leave as 3 times 2x minus 7. Or if you want, you could distribute it and make it 6x minus 21. But you don't have to. Because I told you you didn't have to multiply or distribute through. Then you're done. Was it as terrible as you imagined it would be? I mean, it's not necessarily the greatest, but is it doable? Yeah, it's really just a bunch of problems in one. Adding in the top, adding in the bottom, division turns into multiplying by the reciprocal. Okay, so you're doing lots of different skills all at once. Your homework assignment is here.